Overloading in scope. Okay, ordinarily it is a bad idea to declare a function locally. However, to explain how scope interacts with overloading, we will violate this practice and use local function declarations. Okay. Programmers new to C++ are often confused about the interaction between scope and overloading. However, overloading has no special properties with respect to scope. Okay, as usual, if we declare a name in an inner scope, that name hides users of that name hides users of that name declared in an outer scope. Names do not overload across space. Okay. Okay, so if we have this is a string function read, then we have a print overloads the print function. Okay, so void foo bar, then we have read, we call a read function. Error, read is a bool variable, not a function. Okay, alright, bad practice. Then we have void print int. Okay, so we have declared a function here. Usually it's a bad idea to declare functions at local scope. Right, correct. Okay, void print int. So print value, error print const string and is hidden. This is hidden. Okay, overloads the print function. Then we have this. Okay, print is visible. Okay, calls to print int, but double is hidden. Okay, this here in the last section it makes a type conversion. Right. Then implicit type conversion. So that's okay. Most readers will not be surprised that the call to read is an error. When the compiler processes the call to read, it finds the local definition of read. That name is a bool variable, and we cannot call a bool. Hence the call is illegal. Exactly. The same process is used to resolve the calls to print. The declaration of print int in foobar hides the earlier declarations of print. It is as if there is only one print function available, the one that takes a single int parameter. Okay. When we call print, the compiler first looks for a declaration of that name. It finds a local declaration of print that takes an int. Once a name is found, the compiler ignores users of that name in any outer scope. Instead, the compiler assumes that the declaration is found that the declaration it found is the one for the name we are using. What remains is to see if the use of name is valid. Okay, in C++, name lookup happens before type checking. Alright. The first call passes a string literal, but the only declaration for print that is in scope has a parameter that is an int. A string literal cannot be converted to an int, so the call is an error. The print const string ref function, which would have matched this call, is hidden and is not considered. When we call print passing a double, the process is repeated. The compiler finds the local definition of print int. The double argument can be converted into an int, so the call is legal. Had we declared print int in the same scope as the other print function, then it would be another overloaded version of print. In that case, these calls would be resolved differently because the compiler will see all three functions, so everything would be valid. Then we have features for specialized users. In this section, we'll cover three function related features that are useful in many but not all programs. Okay, default arguments, inline and const expression functions, and some facilities that are often used during debugging. Default arguments. Some functions have parameters that are given a particular value in most but not all calls. In such cases, we can declare that common value as a default argument for the function. Functions with default argument can be called with or without that argument. For example, we might use a string to represent the contents of a window. By default, we might want the window to have a particular height, width, and background character. However, we might also want to allow users users to pass values other than the defaults. To accommodate both default and specified values, we would declare a function to define the window as follows. Okay, so we have size. Okay, we are declaring a size. We have height, size, and then background. Okay. Here we provided a default for each parameter. A default argument is specified as an initializer for a parameter in the parameter list. Okay, we may define defaults for one or more parameters. However, if a parameter has a default argument, all the parameters that follow it must also have default argument. Okay. Calling functions with default arguments. If we want, okay, if we want to use the default argument, we omit the argument when we call the function. Because screen provides a default for all its parameters, we can call screen with 0, 1, 2, or 3 arguments. Okay, so this is equivalent to the default. This is the first value, then we take the second value, and then okay. Right. Arguments in the call are resolved by position. The default argument are used for the trailing rightmost argument of a call. Okay, error can't omit only trailing arguments. The default arguments are used for the trailing rightmost arguments of a call. For example, to override the default for background, we must supply arguments for HT and WT as well. Okay, can't omit only trailing arguments. Okay. So note, the second call which passes a single character value is legal, although legal it is unlikely to be what was intended. The call is legal because this is a char, and a char can be converted to the type of the leftmost parameter. That parameter is a string size type, which is an unsigned integral type. In this call, the char argument is implicitly converted to this and is passed as the argument to height. On a machine, question mark has a hexadecimal value of this, which is decimal 63. Thus, this call passes 63 to the height parameter. Part, okay. Okay, so we have height, then width. Right, thus this call passes 63 to the height parameter. Part of the work of designing a function with default argument is ordering the parameters so that those least likely to use a default value appear first and those most likely to use a default value appear last. Alright. Default argument declarations. Right. Although it is normal practice to declare a function once inside a header, it is illegal to redeclare a function multiple times. However, each parameter can have its default specified only once in a given scope. Thus, any subsequent declaration can add a default only for a parameter that has not previously had a default specified. As usual, defaults can be specified only if all parameters to the right already have defaults. For example, no default for the height or width, so that is okay. We can change an already declared default value, error, redeclaration, but we can add, okay, we cannot, right? But we can add a default argument as follows. Default arguments ordinarily should be specified with the function declaration in an appropriate header. Okay. Default argument initializers. Local variables may not be used as a default argument, accepting that restriction. Local variables may not be used as a default argument. Okay, this is height, right? Accepting that restriction, a default argument can be any expression that has a type that is convertible to the type of the parameter. The declaration of WD, def, and HT must appear outside a function. Okay, then we are declaring a function. So this is HT, WT, and def. Okay. Names used as default arguments are resolved in the scope of the function declaration. The value of those names represent the value that those names represent is evaluated at the time of the call. Okay, so void f2 so changes the value of a default argument, hides the outer definition of WD, but it does not change the default. Calls screen. Okay, so this won't change the default. Alright, names used as a default argument are resolved in the scope of the function declaration. The value that those names represent is evaluated at the time of the. Okay, so we have declared a new variable, hides the outer definition of WD but does not change the default. Okay, alright. Inside F2 we change the value of def. The call to screen passes this updated value. Our function also declared a local variable that hides the outer WD. However, the local name WD is unrelated to the default argument passed to the screen. Alright. Okay, we have this exercise section, which if either of the following declarations are error. int p equals 0, int c equals 0, y h equals 24, right? This declaration is let me start here. The second is an error because everything after the first default arg should also be default arg, right? Okay, so which if any of the following calls are illegal? Which if any are legal but unlikely to match the programmer's intent? Okay. So this is illegal. A legal must provide wait, hold up. A legal must provide a arg for ht as it's not default initialized. Okay, this is okay. Then this is not okay because you have to provide them in order. Can't put uh, right. Oh, okay. No, not really illegal. Uh, this is legal, but not as per the dev intended. Well, implicitly converted to an int. Okay. Give the second parameter of make plural a default argument of s. Test your program by printing singular and plural versions of the word success and failure. Huh. Okay, I think I would have to do this and this. Let's go to exercises. dir. Okay, so I want to make a new directory. Let's make it section. So 6.5.1 and 5.1 cd2 section 6.5.1. We will make a new file. This is called 6.42.cpp. Okay, let's include print if we would need it. Okay, so this question, page number, make plural 2 to 4, and I am on page. Okay, 2 to 4 is not that far away. We can get there. There we go. Get well. Huh. Make plural. Okay, so we have written the plural version. If okay, size g ctr. Okay, the return type of this function is string, which means value is copied to the call site. This function returns a copy of a word, or it returns an unnamed temporary string that results from adding word and ending. As with any other reference, when a function returns the reference, okay, size. Return the plural version of word if ctr, okay, size is greater than 1. Okay, so let's have this. make we are taking a size, then we are taking a string reference word. And what had I? Okay, first I'll complete this const string ending. Then we were returning if this is greater than 1, then you go word plus ending, else we simply return the word. Okay, now coming back, what did I have to actually do? Yep. Okay, so make uh, give the second parameter of make plural a default argument of s, and test your program by printing singular and plural versions of word success and failure. Successes. Second argument word. I think it means this, this. Yes, it is okay. Okay, we can bind a const ref to a literal, so it's okay. Alright, so I have provided a default version. Then we can call this. Let's see, print line. Go singular. Oh, failure. Singular failure is make plural equals 0, and we'll provide fail. And I can copy this and I can go plural of failure is this. Okay, and we can make sorry G++ dash home main. Let me specify the standard. C++. Okay, standard equals C++. C++ 23. Experimental feature. No. G++. G++ is not recognized. You guys, huh? Well, yeah, I don't see that. Okay, so that is actually my bad. Let's fix this really quick. Sys2 MinGW32 pen. Okay. Hmm. Ah, yes. I can remove this. And we can join main. Yeah, failure and failures. Well, successes is I don't success. Well, not grammatically correct, but successes, successes. Okay, inline. Think this will work too. Right, successes. Inline and const expression functions. In 6.3.2, we wrote a small function that returned a reference to the shorter of its two string parameters. The benefit of defining a function for such a small operation include the following. It is easier to read and understand a call to shorter string than it would be to read and understand the equivalent conditional expression. Using a function ensures uniform behavior. Each test is guaranteed to be done the same way. If we need to change the computation, it is easier to change the function than to find and change every occurrence of the equivalent expression. Yes, that is correct. Alright. The function can be reused rather than rewritten for other applications. That is also correct. There is, however, one potential drawback to making shorter string a function. Calling a function is appropriate to be slower than evaluating the equivalent expression. On most machines, a function call does a lot of work. Registers are saved before the call and is stored after the return. Argument may be copied and the program branches to a new location. Inline functions avoid function call overhead. A function specified as inline usually is expanded in line at each call. If a shorter string were defined as inline, okay, then this call would be equivalent to probably would be expanded probably 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 would be expanded during compilation into something like this. Okay, the runtime overhead of making shorter string a function is thus removed. We can define shorter string as an inline function by putting the keyword inline before the function's return type. Okay, inline version find the shorter of two strings. The inline specification is only a request to the compiler. The compiler may choose to ignore this request. In general, the inline mechanism is meant to optimize small straight line functions that are called frequently. Many compilers will not inline a recursive function. A 75 line function will almost surely not be expanded inline. Alright. Const expression functions. A const expr function is a function that can be used in a constant expression. A const expr function is defined like any other function but must meet certain restrictions. The return type and the type of each parameter in a must be a literal type. Okay, the each parameter must be a literal type and the function body must contain exactly one return statement. Okay. So we have const expression return 42. Okay, foo is a constant expression, right? Here, here we defined a new size as a const expression that takes no argument. The compiler can verify at compile time that a call to new size returns a constant expression, so we can use a new size to initialize a const express variable foo. When it can do so, the compiler will replace a call to a const expression function with its resulting value. Okay, in order to be able to expand the function immediately, const expression functions are implicitly inline. A const express function body may contain other statements so long as those statements generate no action at runtime. For example, a const express function may contain null statements, type aliases, and using declarations. A const express function is permitted to return a value that is not a constant. Okay, scale. Okay, so that is not a const expression function is permitted to return a value that is not a constant. Okay, here. Okay, that is what it means by that. But will eventually evaluate to a constant. Scale arg is a constant expression if arg is a constant expression. Right. The scale function will return a constant expression if its argument is a constant expression but not otherwise. So we have 2. Okay, scale 2 is a constant expression. Int I equals 2. Okay, scale. Okay, I is not a constant expression. Right. When we pass a constant expression, such as the literal 2, then the argument is a constant expression. In this case, the compiler will replace the call to scale with the resulting value. If we call if we call scale with an expression that is not a constant expression, such as on the int object I, then the return is not a constant expression. If we use scale in the context that requires a constant expression, the compiler checks that the result is a constant expression. If not, the compiler will produce an error message. A const express function is not required to return a constant expression. Yes. Put inline and const expression function in header files. Unlike other functions, inline and const express function may be defined multiple times in the program. After all, the compiler needs the definition, not just the declaration. Okay, in order to expand the code, however, all of the definitions of a given inline or const express must match exactly. As a result, inline and const express function normally are defined in header. Okay. Alright. Okay. Which one of the following declaration and definition would you put in header in a source file? Explain why. Okay. So A in header because it's inline and its various defin definitions should match across all files. Okay. be a source file, as it may be overwritten. Many times. Okay, rewrite a shorter function to be an inline. Okay, then we have review the programs you've written for the earlier exercise and decide whether whether they should be defined as inline. If so, do so. If not, explain why they should not be inline. Okay. Then we have would it be possible to define is shorter as a const pair? Const, so do so. If not, explain why not. Okay, I can start with this. Uh, okay, we will create a new file called 6.44 CPP. Okay. Mm, print, and we would also need a string. Let's make it inline. Is shorter. We take a const ref. This one. This two. Then we check return s1 less than s2. If s1 is less than s2 is true, then we will return s1, or else we will return s2. Okay. Um, this should work. Right. String A. Let's say hi. String B. Hello. I can simply print line shorter of A and A is here. So we pass in A, B, B is shorter A comma B. Okay, so this is cannot convert to an int. Ah, shit. Returning a reference. A shorter of hi and hello is hello. Okay. EFTHI. Okay. Okay. Yeah, that's correct. All right. Then we say now review the programs you've written. Nope, I'm not doing that. Okay, exercise 6.4.6. This is, I'll say, 6 point, wait. Where am, okay. She's, hmm. Didn't I make 6.5.2? No? Section 6.5.2? There is no section 6.5.2? 6.5.2. Okay, now there is. Okay. Yeah. Okay. Hmm. Okay, I want to create a new 6.4.cpp. I know it is no longer there, but that's okay. I wish to paste this here. And now we will make it a const exper. Okay. So the arguments. Okay, literals. Right. I can. I think if I only pass in literals, I can do that. Let's go. We are creating a const express string. So s equals to is shorter. Okay. Temporarily bind, but I think this should, because we if we temporarily bind to a literal, it would have a new object would be created, right? It would create a new object, and then it would try to pass that object, but it would no longer be in that scope. So we can try to compile it. Okay. 6.46. Let's see. Yeah. Error. Hmm. This is not a constant expression. Right. It's not a constant expression because it refers to an incompletely initialized variable. Okay. Sorry. Hello. Hmm. Okay, would it be possible to define a shorter as a const expert? If so, do so. If not, explain why not. Okay, forget about const experts right now. Right. Right. I want to see what would happen. I don't think that it can return that. Would like hello. Okay. I think I did read a little about this, but now I seem to have forgotten. Line and const expert. Hold up. Let me search a little. Overloading function returning pointers, trailing return types. Overloading function that returns the value. Returning references. Yes. Okay. So we return a const ref in order to make it read only. Right. Okay. So we can only pass plain references to the references in the parameters, but we can't pass references to local variables. Okay. Here's an example disaster. This function returns a reference to a local object. Right. This is the local object. Hmm. Wrong return type. Nope. I think. Let's see. Nope. 6.5.1. I just did that. 6.33. Okay. Returning. Okay. This is mostly with arrays. Okay. Vector. Vectorial with vector. Initialize a list. Um, we are taking pointers, swapping pointers. This contains capital. Hmm. Where are references? Okay, header guards. I seem to forget about. Hold up. Okay, why can we pass a reference? Okay. Okay, yeah. Safe because R is bound to either. Okay, R. Shorter string const s1 and s2. Okay, const string. So return. Yeah, okay. We noted that const casts are most useful. Okay, so then let's do overload function using default type. I want to go to plain references are values. My reference to a char get val assumes a given index is valid. We should go on the left hand side. Ah, okay. Short string. Yeah, error returns the value returned is a const. Okay. If the reference type, if the return type is a reference to const, then as usual we may not assign. Okay. So then let's do. Okay. So ret is a local object and gets destroyed when the function when the function returns. So any reference to it would also get destroyed. Then empty is a string literal const, and since the function return type is a const reference, the compiler will create a temporary string object and bind it to the string literal. However, since the object created is local, it too will be destroyed after the function returns, and again we would be referencing an object that no longer exists. To ensure that return to what pre-existing object is the reference referring. Okay. Okay, both of these return statements return an undefined value. How values are returned? Okay, values are returned in exactly the same way as variable and parameters are initialized. The value is used to initialize a temporary at the call site, and the temporary is a result of the function call. It is important to keep in mind the initialization rules in functions that return local variables. As an example, we might write a function that, given a counter, a word, and an ending, gives us back the plural version of word if the count is greater than 1. Okay. The return type of this function is string, which means the value is copied. As with any other reference, when a function returns a reference, that reference is just another name for the object to which it refers. As an example, consider the function that returns reference to the shorter of its two strings. The parameter and return type are reference to const string. The strings are not copied when the function is called, so or when the result is returned. Okay, so it is okay. Okay, this is okay because hi and hello are not local objects. Local objects. They S1 and S2 just bind to them and are written as as wait, I don't understand this. Is there anything else regarding? Okay. Function that return class types and call operator list initializing return from main. Okay, so let me take the help chat GPT. Let's take an example function. Since we should not return, so local objects. Mm. Current question: temporary lifetime extension becomes important, and thus, yeah. What actually happens? The implicit temporary creation, the string literals are these types. Hmm. Because the function expects, the compiler creates temporary string objects, right? Lifetime extension. A temporary bound to a const reference parameter lives until the end of the full expression containing the function call. Lifetime extension, a temporary bound to a const reference. A temporary bound to a const reference, so lives until the end of the full expression containing the function call. So inside the function, s1 refers to temp1, and both temporaries live until the full expression ends. The critical part, the full expression here is, after that line finishes, both temporaries are destroyed. So is this call valid? Yes, if you don't store the returned reference. This is fine because temporaries live until end of the full expression. Cout happens within the same full expression, then the temporaries are destroyed when it becomes dangerous. Now what happens? Okay, so temporaries are destroyed at the end of the full expression, but ref tries to refer to one of them. That reference now dangles. Undefined behavior. Why this is different from returning a local variable? Destroyed before caller even gets it. Always wrong. It'll get the end of the function. But in your case, the object were created by the caller. Their lifetime was extended for the duration of the full expression. So the function is not returning a function to its own local object. big difference. The subtle trap. This is why many modern C++ guidelines recommend do not return const reference from function that accept const reference parameters. Instead, return by value. Okay, so this is do not return const reference from functions that accept const reference parameters. Okay, that's why they had those functions. Where is it? Where is it? Where is it? Const cast. Mm. Hmm. You have this function const string this string shorter string. Okay, valid because this is okay. This function takes returns a reference to a const string which we know is bound to one of our original non-const arguments. Therefore, we know it is safe to cast a string back to plain string reference. Safe because R is bound to either S1 or S2, which in turn are both plain ref. Okay. Function matching. Okay. So the function is safe. The usage might not be safe. Safe, unsafe. Okay. All right. Okay. So now I understand that. Nope. Not object. They are declared. Okay. So this is okay because hi and hello are not local objects. They're declared by the callee. Hence, the temporary objects that are bound to them. Okay, I'll be just getting it done. Them have an lifetime extension until the evaluation of the expression, that is the function itself. That is the function itself. Okay. Can I copy the value to a regular string? Can I assign the value returned by this function to a regular string? Yes, you absolutely can. Using a function, you can safely do. Why this is safe? So to hi and hello, create temporary string objects. They are bound to parameters. The function returns a reference to one of those temporaries. That reference is used to copy initialize. After the full expression ends, temporaries are destroyed, but S now contains its own independent copy. Okay. So you can use them in a print call because the temporary objects are still alive. The function call is alive. Same line. But you can't have a reference to the result those because the temporary objects that point to the temporary objects that are pointed by the const references will be destroyed and will become a dangling reference. However, we can assign the value of the result to a regular string because it will copy initialize the string using the const reference. So the new string will have its own independent copy and would not be depending on the temporary objects. Okay, I'll come back to this.